Good day everyone, I am here to present Heme-oxygenase 1 as a novel drug for cardiovascular disease, particularly arteriosclerosis. Disease-wise, arteriosclerosis is an inflammatory disease of lipid deposition in the arterial wall, resulting from elevated levels of plasma cholesterol, which is central to lesion development. So technically, arteriosclerosis is the hardening and narrowing of your arteries. It can put blood flow at risk as your arteries become blocked. You might hear it called arteriosclerosis or arteriosclerotic cardiovascular disease. Drug-wise, moreover, heme-oxygenase 1 is an enzyme that catalyzes the degradation of heme. This produces biliverdin, ferrous iron, and carbon monoxide. It is present throughout the body with highest concentrations in the spleen, liver, and kidneys. Previous studies demonstrated that expression of heme-oxygenase 1 is prominent in endothelial cells, macrophages, and foam cells in human and animal atherosclerotic lesions. It was also shown that inducers of heme-oxygenase 1 reduce lesion size in hyperlipidemic rabbits. There are additional lines of evidences in support of heme-oxygenase 1 play a protective role in atherosclerotic lesion formation, such as the presence of HO1 in human and experimental atherosclerotic lesions. High serum bilirubin levels are associated with decreased risk of a coronary artery disease, and low serum bilirubin levels are associated with increased risk coronary artery disease. Remember, I mentioned earlier that HO1 produces biliverdin. Together, the mentioned results strongly support the notion of heme-oxygenase 1 plays a protective role in experimental atherosclerotic vascular disease. Although the relevance of these findings to the human disease has yet to be established, the overall outcome of the preclinical studies carried out to date clearly points to HO1 as a potential novel target for the therapy. It is clear in this article that heme-oxygenase 1 exerts vasoprotective effects. Heme-oxygenase 1 indeed has excellent reviews and is potential as novel drug for cardiovascular disease. Through such experiments, probable and potential substance agents are examined and developed to optimize its utilization that has never been erased before in previous studies and researches. However, after reviewing this article, we must raise the question of whether prolonged induction or high levels of heme-oxygenase 1 expression had adverse consequences. As HO1 degrades heme, long-term increase in HO1 or induction of HO1 to high levels of expression could conceivably lead to heme depletion and associated adverse consequences such as loss of cellular heme process required for normal cell formation. All in all, as experimental work continues, answers to important questions will likely to be found, like what has been presented in this article, where they questioned the beneficial activity of heme-oxygenase 1 to cardiovascular disease. At the end, they got positive results that could be a great tool against the aforementioned disease.